We're going to use curve sketching techniques to sketch the function y equals 1/2 x plus sine of x over the interval from negative pi to 2 pi. So the domain has already been set for us, and so we'll begin by finding the first derivative. So if y equals 1/2 x plus sine x, then y prime equals 1/2 plus the derivative of sine is cosine x. Now, if we want to find critical points, those are going to be points where the derivative is either 0 or undefined. Notice that since cosine of x is never undefined, 1/2 plus cosine of x is never undefined. So we really just need to find where 1/2 plus cosine of x is equal to 0. So we subtract 1/2 from both sides, and we really need to find out where is cosine of x equal to negative 1/2. Now we're looking for all such values on the interval between negative pi and 2 pi. So if we think about our unit circle, sorry, that's a little crooked. We're going from negative pi, and then we're wrapping around another full rotation all the way until 2 pi. So cosine of x is going to equal negative 1/2 in, remember cosine corresponds to the x coordinate on the unit circle. So we're looking at values in the third quadrant and in the second quadrant. That's where cosine is going to be negative. So we're going to get 3 such values. One is going to be a negative value. So we're going to get x equals negative 2 pi over 3. Then when we wrap around to the first quadrant, we're going to get the positive 2 pi over 3. And then in our last swing around in the third quadrant again at 4 pi over 3. So what we want to do now is we want to find out what's happening in between these critical points. These are places where the derivative is 0. So they are potential local maximums or minimums. So in order to figure out which one they are, we have to look to see if where the graph is increasing and decreasing. So we're going to test values in the interval between negative pi, because that's the leftmost part of our domain, to the first critical point. Then the next interval will be between the next 2 critical points, so between negative 2 pi over 3 and positive 2 pi over 3. Then from 2 pi over 3 to 4 pi over 3, and finally from 4 pi over 3 to the end of our interval. The end of our domain, 2 pi. And let's see if I can draw a somewhat straight line here. Okay, so what we want to do is we want to find out if the derivative is positive or negative in these intervals, and that'll tell us if our graph is increasing or decreasing. Sorry about those lines. Okay, so we're going to look to see what's happening at y prime. That'll tell us about y. Okay, so I want to pick a value for x in between negative pi and negative pi, 2 pi over 3. So this is roughly negative 3.14. This is roughly negative 2.09. So maybe we want to pick a point like x equals negative 2.5. So what can be a useful tool for this is your graphing calculator. I'm going to go to my graphing calculator, and in my y equals, I'm going to plug in the derivative, 1/2 plus cosine of x, because I want to evaluate this derivative at several points. Now, if you just go to the table as it is, it's just going to list a bunch of values, but you can't customize the ones that you want. So I'm going to change it to my table settings so that it asks me for the independent value. Now when I go to the table, table, that's not table, second table, there it is. If I want to choose a value like x equals negative 2.5, which is what I wanted to do, oops, what's going on? Hold on. Okay, sorry, the problem was that I put in the wrong negative sign, so it was negative 2.5, and when I push enter, I get a negative result. And I don't need to know what the value is in particular, but I see that it's negative. So when I go back to my chart, I see that here, this is going to be a negative value. This tells me that the graph is decreasing here. Now we want to pick a value between negative 2 pi over 3 and positive 2 pi over 3, so I think 0 would be a good value for that. So back over here we can type in 0, and we see that we get a positive result. So we can input that into our table. This is positive. This is going to be increasing. Again, now I want to pick a value between 2 pi over 3, which is roughly 2.09, and 4 pi over 3, which is roughly 4.1 something. So maybe I could pick x equals 3. So let's go back over to here. And we see we get a negative value. So over here, that tells me my graph is decreasing here. For time's sake, I'm going to jump ahead and tell you that this is going to be positive, and this will be increasing. So we see that the graph is going from decreasing to increasing. So if a graph goes from decreasing to increasing, we're going to get a local minimum. So we're going to get a local minimum at negative 2 pi over 3, comma, the way we find the y-coordinate is we have to plug negative 2 pi over 3 back into the original function. So 1/2 times negative 2 pi over 3 plus sine of 2 pi over 3, and we're going to get a value of approximately negative 1.913. At our next critical point, we're going from increasing to decreasing. So we're going from going up to going down. So in between, we're going to have a local max. So that's going to be at 2 pi over 3. And again, plugging that into the original function, we actually get positive 1.193. And finally, as we go from decreasing to increasing, we get another local min. Local min at 4 pi over 3, comma 1.228. Okay, so that tells me about the first derivative. I need to do the same thing again for the second derivative in order to find my inflection points. So my first derivative was 1/2 plus cosine of x. So my second derivative is just going to be 0 minus sine of x, or negative sine of x. Again, we want to find where the second derivative is either 0 or undefined. Since sine of x is never undefined, we're only looking for places where negative sine of x is equal to 0. And again, we're looking for all such values between negative pi and 2 pi. So those are going to be the values at negative pi, 0, pi, and 2 pi. Now, negative pi and 2 pi are already the endpoints of our intervals, so we're just going to need to check between negative pi and 0, between 0 and pi, and between pi and 2 pi. What we're going to be checking for now is what's happening to the second derivative, and that'll tell us about the concavity of our original. Okay, for time's sake, I'm not going to go through the whole exercise again with the graphing calculator. I'm just going to tell you that in this interval, we get a positive second derivative, in this interval, a negative second derivative, and here a positive. So this tells me that my graph is concave up, then concave down, and then concave up again. So we have inflection points where it changes concavity. So we have inflection points at 0, 0. If you plug 0 into the original, you get 0. And also at pi, approximately 1.571. Okay, so, by the way, the endpoints at negative pi and at 2 pi are also inflection points, but we don't need to worry about that because we're only sketching on this very small interval. Okay, so I'm going to see if I can squeeze the graph in here and see how well I can actually graph with this pen. So we're only going from negative pi, maybe that's pi, 2 pi. We know it's going to pass through 0, 0. I'm going to plot some of these points that we have. So we have 0, 0. We have at pi approximately 1.57. That's an inflection point. I know at negative, let's break this up into thirds, negative 2 pi over 3, we were down at negative 1.93, something like that. And let's see, what other points do we have? We have at 2 pi over 3, we have a local max up at 1.93, so that's maybe up here. And at 4 pi over 3, we have a local minimum somewhere around here. Okay, so I'm not going to get too exact, but we're going to get something like, here's an inflection point, and then, oops, I missed my minimum. You guys have to bear with me on that. That point was supposed to be my minimum. So I have a local minimum here, a local maximum here, local minimum, and then an inflection point here and here. Okay, so let's just double check to see if this graph looks right by going to our graphing calculator. Now we're going to plug in our original. So I'm going to clear this out. And I want to graph 1/2 x plus sine x. By the way, make sure you are in radian mode for this. And let's see, let's graph. Now it looks like we're going a little more than, so our window must be bigger than we need. Let's just go from negative pi to 2 pi, so it looks like the same interval we want. And there it is.